What if you could learn assembly language without installing anything? Just open a browser, write code, and watch every register change. This project is a Rust-based emulator for the COR24 instruction set. COR24 is an existing educational RISC architecture, and this emulator brings it to the browser using WebAssembly. COR24 is a 24-bit RISC instruction set with over 200 instructions, 3 general-purpose registers R0 through R2. There are 5 special registers for the frame pointer, stack pointer, interrupt vector, and return address, a read-only zero constant for comparisons, and a single condition flag. The COR24-TB Board is a lattice FPGA with 1 MB of SRAM for programs, 3K of block RAM for the stack, and a 16 MB address space. Memory mapped I/O gives you an LED, a push-button switch, and a UART for serial communication. My tools are written in Rust. 2 emulators simulate the board, one for the command line and one compiled to WebAssembly for the browser. Both assemble source directly to bytes in memory, no linker or loader. A translator converts MSP 430 assembly from the Rust compiler into COR24 assembly. 3 tabs, 3 demos. The Assembler tab lets you write and edit code directly. Assemble to machine code right in the browser. The C and Rust tabs show pre-compiled examples. No compiler runs in the browser, just the assembler and emulator. The built-in tutorial covers the full instruction set. Getting started steps, register descriptions, then sections for arithmetic, logic, shifts, compares, and branches, each with example syntax. It also covers stack operations, function calls with jump and link, and the memory mapped I/O addresses for the LED button and UART. Instruction sizes range from 1 to 4 bytes. Tips at the bottom suggest examples to try. The challenges section suggests things to try on your own. Write a program that adds 2 numbers or one that counts down to 0. A future version may score your attempts. For now, it is a starting point for practice. The ISA ref button opens a full instruction set reference right in the browser. It covers the program counter, condition flag, and all 8 registers. And then every instruction category, load constants, arithmetic, branches, memory access, and stack, plus interrupts, the memory map, and assembly syntax. The help section explains how to use the emulator. Write your code, click assemble, then step through or run to completion. Watch the registers highlight as values change. The COR24 toolchain also works from the command line. You can write assembly in any editor, assemble it to machine code, and run it on the emulator. Let's see how. This is a UART Hello World program in COR24 assembly. Each character is loaded into R0 and sent through a putc function call. The main code loads HELLO and new line, calling putc for each one. The putc function shows how memory mapped I/O works. It saves registers to the stack, loads the UART base address, then pulls the transmit busy flag in a loop. Once the transmitter is ready, it writes the character byte and returns through the saved return address. Now we assemble and run with COR24. Run the assembler produces 60 bytes of machine code. The UART output section confirms the peripheral state, and the captured transmit log shows the complete hello string sent 1 character at a time. The instruction trace logs every UART transmit event with the character and its hex value HELLO and new line, all written through memory mapped I/O. The final output line confirms the assembled string. The final CPU state dumps all registers. The program counter, condition flag, R0 through R2, plus the frame pointer and stack pointer at its initial value, from assembly source to machine code to UART output, all from one command line tool. COR24 makes assembly accessible. No installation, just a browser. Visual debugging shows exactly what happens at each step. Built-in examples teach concepts progressively, and challenges let you verify your understanding. See how computers really work at the instruction level. The Showme Tour walks through the Assembler tab. The examples dialog lists programs like Blink LED, Countdown, and Fibonacci. After selecting Blink LED, the code assembles into hex opcodes and the emulator starts running. The LED toggles on screen as instructions execute. The instruction trace shows the loop pattern: load, store, branch, repeating. You can step through one instruction at a time or let it run continuously. The C tab uses MakerLisp CC24 compiler to go directly from C source to COR24 assembly. The examples dialog offers Fibonacci and sieve of Eratosthenes, 3 steps: source, compile, assemble. After selecting the prime finding sieve, the compiler generates COR24 assembly and the assembler converts it to machine code. The program runs and prints results through the UART. The instruction trace shows the sieve loop eliminating composite numbers. The Rust tab shows a 4-step pipeline. Rust source compiles to SP430, then translates to COR24 assembly and assembles to machine code. The Blink LED example defines memory-mapped I/O addresses and a delay loop. After compiling, generated assembly runs in the emulator. The LED toggles as the delay loop counts down. The instruction trace shows each step of the compiled Rust code executing on the COR24 CPU. The self-test mode runs all 15 examples automatically. Each test validates a specific result, memory values, UART output, register state, or instruction count. 15 tests, 15 passed, 0 failed, all green. 3 tabs, 1 emulator, write assembly, compile C, or compile Rust, all running on the same COR24 CPU in your browser. Animated tours show the workflow. Self-test validates all 15 examples automatically. No install needed. All the documentation links are in the description below. The live demo, source code on GitHub, hardware documentation at makerlisp.com, and software documentation built into the app. Try COR24 yourself. The live demo is linked in the description. All you need is a modern browser. If you enjoyed this video, like and subscribe for more Rust and WebAssembly projects. If you found this helpful, please like and subscribe, hit the bell for notifications, and leave a comment if you have questions. See you in the next one. Bye.